Okay, in this demonstration we're going to embed a secret text message inside this image after first encrypting it with RSA encryption, and we're also going to send it to the cloud. So what we need first is an empty cloud bucket, just to show you who it is. That's empty, nothing in it. Okay, let's go back to Python. Okay, Stego, let's build it. Okay, welcome to Stego, cryptography, steganography, and the layered onion approach to cybersecurity. As you peel the layers back like an onion, every layer is another layer of security. Okay, RSA encryption. Okay, let's select our cover file. Okay, there's our line image, just to show you. There it is there. We're going to embed in that. Okay. Right, so okay, at this stage we can add a hash function, SHA-256, which is basically just a digest encryption key, which if it undergoes any change whatsoever during transmission, it won't come out the other end exactly the same, and we'll know someone's intercepted the message. It'll fail. It's just an extra layer of security. Okay, so we've selected our line image, enter our secret message. Hello, Yvonne, and come on. Okay, click to encrypt. Okay, now it's worth noting that we could actually embed a complete file, which will be shown in a later demo, but for this simple demonstration it's a simple text message. So click to encrypt. Okay, so there's OpenSSL running in the background, which I'll just show you is all this. So what we're doing here is we're randomly generating a private key, which we use to generate a public key for user A, which is Bob, and a public key for user B, which is Alice. Okay, that is our asymmetric encryption. Okay, the private key, which only we will have knowledge of, obviously. And there's our signature key, which is the one-way hash function. That shouldn't undergo any change to prove its validity. And we'll also convert it to base 64, which is makes it a little bit easier for transmission and send through emails, bits and bobs like that. Okay, so we will send it to our encoding function. Here's our original image, and it should have produced this image, which we will have a look later, which I think we're about to send it to our algorithm. There it goes, sent. Okay, and there's our image. So that will have the encrypted text message in it. Okay, so let's create that. Now let's go and have a look at our cloud bucket. It's nothing there. Okay, let's F5 refresh. Should, with any luck, pop up. Here we go. Okay, there is our Stego image. There it is, with our encrypted text message within. At this stage, it's worth noting that this is only using Google's Google managed encryption key. Now we could obviously use our own encryption keys, which could be our private keys or our own randomly generated keys as an even extra layer of encryption. It's just using default Google, so that's just an extra layer. So there's our image. Okay, let's go back to Python and try and retrieve it from the crowd. So that means just running all that in reverse, so this will be Alice's job here front end. Okay, Alice, let's go and fetch the file from the cloud. There it goes. Just to show these cloud functions while here. These are quite important. Google Cloud Send, using a JSON credentials file to prove who we are. So we'll give ourselves access by both ends, and then obviously just to retrieve it. Okay, so we've got the image. Now that's not good to us just like that. We need to decode our image from decode our message from the image. Okay, and there it is, and that's still no good really because it's gobbledygook, it's still encrypted. So what we want to do is run OpenSSL in reverse, decrypt it. There's our message, decrypted. Hello everyone, I'm Cameron, spelt rather iffily, but it doesn't matter. Okay, now the last stage, as we said before, is to verify using the hash key. Now this should have no alterations in it. If it has, then we know someone's been messing around halfway through transmission or whatever, interception. Okay, so let's verify it. This was definitely sent from user A, Bob. Brilliant. So okay, we know that's kosher, and that's it, job done. And quit that. We can have a look at our original image, which is that. We can have a look at our secret Stego image, and there's no visible difference, there's no legible difference, which means it's worked. Now this works on using our least significant bit algorithm, which is this. Now this works by using some clever bitwise AND operations and ones complements on the ASCII values of the least significant bit values of the red pixels, which will be dispersed within this. It's called least significant bit because you literally cannot tell the difference. You can't tell what's been altered. So it'll be a value of 1 here or there dispersed throughout the image, and you won't be able to tell. And this works on bigger files as well, CSV files, which will be proved in a later demonstration. So that's it, proof of concept, that works, job done. Thank you.